Hello guys, so we are going to continue the discussion with respect to multiple linear regression, and we'll try to see that how we can probably implement or how we can train a multilinear regression model using Python and sklearn. Now for this, again, understand the differences between a multiple linear regression and a simple linear regression is that in a simple linear regression, you just have one independent features. Whereas in multiple linear regression, you can have more than one independent features. So that basically means you'll be actually finding out multiple different coefficients and slopes based on the number of independent features. Okay. So for this, I'm going to consider a data set, and this is a house pricing data set for California city. Okay. So in order to import this data set, I will go ahead and write from sklearn.datasets import fetch California underscore housing. Okay. So once I execute this, along with this, I'm also going to use some of the common libraries. So obviously we require pandas, numpy, seaborn, matplotlib and all. Okay. So I'm going to import all these libraries over here. Now, in order to download this data set or probably use this data set, what I'm actually going to do over here is that I will just write, let's say California, okay, underscore data set. Okay. Or I can just go ahead and write something called as data set is equal to, and here I'm going to basically say about fetch California housing. Okay. So once I do this, once I initialize this particular class, you can just say that, then I will probably be getting the data set. Now inside this data set, okay, so let me rename this data set as California. Okay. So California. So I will just say California. Perfect. So once we go ahead and execute it, now if you probably go and see California, you will be able to see many things. Okay. So here you'll be having some key value pairs like data, you'll be having target, you'll be having frame, you'll be having target names, you'll be having feature names, and a lot of information like description. Okay. So if you really want to understand what all things are there, first of all, just go and search for california.keys. Okay. Now this keys are basically saying that what all information that you have, right? Now this California, if you probably see, it is a kind of dictionary. Okay. So if I probably go ahead and write type of California and execute it, here you will be able to see that this is like a sklearn.utils underscore bunch.bunch. And inside this bunch, okay, you will be able to see that you'll be having a dictionaries also. Okay. So if I probably just execute this, let's say if I go ahead and execute California over here, okay, and if I execute it over here, so here you can see data is one dictionary and this is all my values with respect to the array, right? Then target is another dictionary and then you have all these values as in the form of array. So likewise, you'll be able to get all this information. Now, if I probably just go ahead and write California.keys, here you'll be having data key, target key, frame key, target underscore names key, feature underscore name, and a description about this data set. Now, as usual, first I will just go ahead and write print, okay, California.descr. Okay. So I'm basically trying to see what is the description of this entire data set. Okay. So here you can see it is a California housing data set. Number of instances. So you have 20,640 records in this. The number of attributes are 8 numeric. Okay. So here you have values like the features, the independent features you have something like mid INC, that is nothing but medium income in the block group. Then this is house age. So this is nothing but a medium house age in the block group. So here you also have average rooms. So average rooms of rooms per household. So these are some of the important independent features that you specifically have. Okay. Now, considering this important independent features, we need to predict something. We need to probably predict the price. Let's go and see what is the target name. Over here, you'll be able to see the target name. Now, if you want to know the output feature, I will just go ahead and write California.target underscore names. So if I go ahead and write over here, California. So again, I'm missing A all the time. I don't know why. Target underscore names. So here, median house value, this is nothing but this is basically the price. The median house value is basically my output feature. Okay. So again, I'm repeating it, guys. These are all my independent features. You will be able to see in the description what each and every feature is all about. And then this will basically be my output feature. Okay. We need to predict this considering this all independent features itself. Okay. So fine, this is very much simple till here. Now, if I really want to know the data, so for the data, I will write print California dot data. So once I execute this, so this is my entire data set. This is my first row of data. This is my second row of data for this particular features, for this all features, right? So this is my first row, then this is my second row, this is my third row. Like this, I will be having 20,000 data points, okay, row wise. Okay, so 20,000 rows will be there, more than 20,000. So if you probably go and see over here, it is nothing but 20,640 rows. Okay, so all those information is there with respect to the data. Okay, and if you probably want to find out what is the target output, so here you will just go and write California dot target key. Okay, and once I execute it, this is what is my target, right? My output features with respect to this input feature. So if I consider this is my first input, first data point or first row of data points with respect to the independent feature, then this particular value will be my output feature, which is nothing but the price of the house. Okay. Now what I will do, I will use all these keys and probably convert this into a data frame. And if I really want to find out what are column names are there also, here there is something called as feature names. Okay, so California dot feature name. So if I go ahead and write something like California dot feature name, and if I execute it here, these are all my features, right? So if I have all these things, I can definitely convert this into a data frame. Now what I will do, I will go ahead and probably create a data frame. So in order to create the data frame, all I will be doing is that, so here I will write a comment, and let's say, I will say, let's prepare the data frame. And this is what I can basically say the data collection strategy or data preparation strategy. So here I'm going to write data set is equal to pd dot data frame. Okay, now I know where my data is basically present. My data is basically present over here in California dot data. So I will going to use this California dot data over here. Now you also know what is your column names, right? So column names, so here column names, and for this column names I'll just be using California dot feature names, right? So here I will have this California dot feature names. Based on this two information, I will basically able to get it. So let's go and see this, and let me write it as dataset dot head, right? Dataset dot head. So if I execute this, this is all my features that I'm specifically able to get, right? I have all these features over here, and these are all my values. Okay, so I hope you are able to see that. And remember, this is basically my independent feature, right? All my independent feature. Now I also need to add the dependent feature. So I will write dataset of price. I know it is a median house value. I'm just using it as something called as price. So for price, I will just write California dot target. Okay. So now if I go ahead and see my dataset dot head, you'll be able to see that I will also have this price feature. So we will take all this as my independent feature, and this will basically be my output feature or the dependent feature. Now, since we have more than one independent feature, we definitely have to use multiple linear regression to solve this particular problem. Okay. Now, basic things, obviously you'll know what all things we need to do. You can find out dataset.info, which we have already seen. What is it? Floating type or object type, whether the data set is having the missing values. These all things we have done it, right? Is null dot sum, right? If I probably write like this, I'll be able to see the missing values, and right now no missing values are there. If I want to see the summary, the descriptive statistics of this entire data set, I can basically use dot describe, right? So this will basically give me the dot describe. Now these all are very much common on functionalities, and if you quickly want to also see how the features are, because these all are independent, these all are numerical features, right? So I can also use import cbon as SNS. Okay, cbon, this is a visualization library as SNS. I hope everybody knows it now. I will use something called as pair plot, and let me just go ahead and give my data set. Okay, so if I probably execute this, I will be able to get the pair plot, and instead of using this also, I can probably just write dataset dot corr. Okay, correlation, and here will basically give the correlation with respect to one feature to the other feature. If it is negative, then that basically means if the house age is increasing, your median, this value will decrease, right, by this particular level. So all these things will basically talk about the correlation, right? And if you also want, I can also use heat map, right? So if I write import cborn as SNS. I want to probably draw this in the form of diagram. So I'll write heat map, and this will be dataset dot correlation. Sorry, CORR. So once I execute it, and I'll make this as anode is equal to true so that I get the values. So this is my axis plot that is basically getting created. So amazing it looks, right? Now here you can see longitude and this feature latitude, right? They are having a negative high correlation. Here also latitude and longitude minus 0.92, right? Which is very important feature altogether. The price, you can see almost all the features are having some negative or positive correlation. With this, it is definitely having 69% correlation, right? Now, all these things are definitely there, right? You can also probably see how is the relationship with respect to population to all the other features by using the scattered plot. But again, our main aim is basically to create a model that is the multiple linear regression model. So as usual, first of all, what I will do, I will go ahead and divide my data into independent and dependent feature. Okay, so this will basically get divided over here. Now, for doing this, I know, right, out of all my data set, this all will be my independent feature and price will be my dependent feature. So in order to basically take all those independent features together, so if I go ahead and write df.head, right, now, this is dataset.head. So here you can see that I will be having 1, 2, 3, 4, 5, 6, 7, 8. 8 is my independent features. Now in order to get all these features, I can basically write dataset.iloc. I will say take all the records, but take all the independent features till here, longitude. And in order to get till here, what I'll do, I'll say colon. From all the columns, I will just subtract the last. I'll just remove the last column. And this way, I will be able to get my X value, which will be my data set. Okay. So this is very much clear. Similarly, for the Y, what I will do, I will just write dataset.iloc. And here I will say colon, comma, -1, only the last column, because Y will basically have the dependent feature, X will have the independent feature. So here I will just write the comment. This will basically be my independent features, and this will basically be my dependent features. Perfect. So let's go ahead and execute over here. And finally, you'll be able to see x.head. And here is all the features that you specifically have. Okay, perfect. Now what we will do is that we will try to, after we created this independent and dependent feature, the next thing that we will do is that we will try to split based on the train test split, right? Which we specifically did in the simple linear regression. So from sklearn.model selection, I will go ahead and import train test split. Okay, so this will basically be there. And quickly what I will do, I will just copy this code so that, because the train test split will give you 4 variables. One is your x train and x test, y train and y test. Here the test size that I have taken is 33% and the random state is 10. The reason I took 33% because we have 20,000 records, more than 20,000 records, right? So if I probably go ahead and execute this, I will probably get my x train dot shape, or I can also go ahead and write dot shape, right? And this will probably give me this many number of records. So 13,828 records will be in the training data set, and remaining all records will be my test data set. Okay, you can probably check out all the shape as we have checked. So for the y train dot shape also, you'll be able to see I'll be having this many number of records. This 8 indicates that many number of columns. Since in my y train only I have 1 column, so it will not have any column over here, right? Similarly, I can go ahead and write x_test dot shape. Okay, all these things are there, and y_test dot shape. Okay, perfect. We are very much good to go. Now the next step is that, obviously, since we are using multiple linear regression, we need to standardize this specific data set also. Now in order to standardize, again, remember all these things, because again, no need to by heart it, but at least remember this, what all things we really need to do. For standardizing, for scaling it down, we can basically do it with the help of standard scaler. In short, we are basically applying z-score on every value. So from sklearn pre-processing, I will import standard scalar, right? So this standard scalar will be there. I'll initialize standard scalar, and I hope everybody knows this, how to use this now. All I will be doing, I will say scalar dot fit_transform on my training data set. So if I probably write X train, now you will be able to see that all my values will get scaled down, right? And we need to do it for the training data set, right? Fit underscore transform we need to do. Now this I will save it in my X train, and for my X test, and we don't do this for the output feature, okay? For my X test, I will write scalar dot transform. We don't need to again do fit underscore transform because we don't want to compute the mean and the standard deviation that will basically be used in the Z score. We'll use the mean and standard deviation from the X train, okay? My model should not have any idea about this specific X test data, right? So here I will go ahead and write X test. Perfect. This both has been executed. Now I will be able to see my X train and X test. So this is my X train and this is my X test. Okay. All they have been scaled down. Okay. Now till here it is perfect. Now let's go ahead with the model training. Okay. So model training. Again, what we need to do for the model training, it is very much simple. We will go ahead and write from sklearn dot linear model import or linear regression, right? So this is the model that we will specifically be using, that is linear regression. Once we execute it here, you'll be able to see that I will just go ahead and create my object regression is equal to, and this will basically be linear regression. We will initialize it. Okay. So this way, if I probably go and see my regression, it will basically be a linear regression. All I have to do after this is that when we are creating this linear regression, right? This regression, we need to just fit with the training data. So my X train and Y train. Now, obviously here we have 8 different features. We cannot see the diagram. It is impossible to draw a 8D diagram, right? So we'll try to fit it, but understand one thing, once we do the fit, right? And now if I try to see the coefficient, so if I write regressor dot coef, right? And execute it. So here you'll be able to see 8 different coefficients. 1, 2, 3, 4, 5, 6, 7, 8, right? So what does this indicate? For every feature, for median ing, you have a coefficient. For this house age, you have a different coefficient or slope, right? All these slopes and coefficient has been calculated by the regression, right? And similarly, if I go ahead and write with respect to the intercept, as we know, there will only be one intercept all the time. So here you can basically see the intercept value. Okay. So this way you are able to get the intercept and coefficients, right? So this will basically be my slope or coefficients. And this will basically be your intercept, right? Intercepts, right? Perfect. Now let's do the prediction. Now we need to do the prediction for the test data. So in order to do the prediction for the test data, all I will be doing is that I will just use the same model regression dot predict, and I will give my X underscore test, and this will get saved. Let's say over here as ypred. I will just write it down. Okay. So here is my prediction. If I probably go and see my ypred, you'll be able to see these are my predictions with respect to my the model itself, right? Now the next thing is that obviously we need to find out the R squared, the adjusted R square, and all, right? So I will directly copy the code what we did for the last time. So performance metrics, mean squared error, mean absolute error, and the root mean squared error. Here I will just say y underscore pred. Okay. Here also I will say y underscore pred. And here also I will say y underscore. Our main aim is that this error should be less, right? And we are able to get this error as less because all my output values in the form of decimals. Okay. It's okay. So here, this is what we are specifically getting with respect to mean squared error, mean absolute error and all, which is very, very good. We are probably getting the best thing over here. Now with respect to the R squared and adjusted R squared. So let's go ahead and calculate the R squared and adjusted R squared so that we get the accuracy. Okay. Adjusted R squared, right? Accuracy of the model. So for this, again, I will go and import R square like this from sklearn.metrics. Then we'll give R2 score, give our y test and reg preds and print score. So this will basically be my y underscore pred. Okay. So finally, you'll be able to see that I'm getting 60% of accuracy, which is obviously very less. Again, if I probably try to compare this with y underscore test. So here, this is what I'm getting 1.64 This is there. Okay, so fine. This is 60% of accuracy that we are able to get with respect to this particular score. Okay, and again, let's see if I probably use the same regression, whether it'll improve or not. Okay. Yeah, so probably I'm getting the same thing. It is coming somewhere around 60%. Not a worries. We can improve this obviously by using different techniques. And if I probably see this kind of distribution of the data, right, it may not be completely distributed. It may be scattered here and there. Okay, it may not have that linear property, so the accuracy will be less. Okay, so here I'm able to achieve 60% over here. Now similarly, if I go and probably see with respect to the adjusted R square, so here I will just copy and paste this adjusted R square, and here I'm using 1 minus score, then a length of y underscore test minus 1. I hope you know the formula of the adjusted R square. So here also I'm able to get 59.31%. Here I'm able to get 59.35%. Okay, this is the problem with respect to multiple linear regression, because if my data is not linearly scattered, maybe we will be getting this kind of problem statements, right? And our accuracy will be less. Now, in order to understand whether our prediction was good or not, there are some assumptions. And here I will just go ahead and write my assumptions. Okay, assumptions. These assumptions, everybody should know it. First is that if I try to plot my y test and my y pred. Okay, so if this is my y pred basically means the prediction for the x test data. Okay, then you will be able to see I will be getting this kind of distribution. Okay, now this distribution that probably looks over here, it has some linear properties, but a lot of data is somewhere here, right? So since it is having some kind of linear properties, I can say, okay, fine, we can probably get this much kind of accuracy that our model is fine to probably do the prediction. Then we will go ahead and calculate our residuals. Okay, so this is nothing but y test minus y underscore pred, and this residual, if we go and see this residuals, right? So if I probably go and see my residuals, so here are all the values. It can be a negative or positive value. If I try to use this residuals inside a dist plot, I will be able to get this kind of normal distribution. If I'm getting this kind of normal distribution, then we feel that yes, the model is performing well, and we can still improvise the model as we go ahead with by using different algorithms, right? Now the final thing is that if I try to plot the residuals with the prediction value, okay, now here you will probably be getting this kind of distribution, but here you can see that, okay, fine, this does not look like a uniform distribution because you can see a linear pattern. What does uniform distribution means? That there is no such kind of patterns in the distribution that you will be seeing. Here definitely you can see a lot of patterns. So yes, you can definitely say, since the accuracy of the model is less, this may not be a good model, and we have to probably apply different kind of algorithms to perform well. Okay, so this were the assumptions that we can probably make with respect to any linear regression. Okay, and obviously guys, if I talk about regression, right, in linear or multiple linear regression, right, since we just focus on creating a straight line or a plane, right, the accuracy will not be that good, right? And again, as we go ahead, we'll be learning about different algorithms like ridge, lasso. We'll try to see, and there'll be other algorithms like decision tree regressor, random forest regression, and all, from which this kind of performance of this particular models will start increasing. Okay. So guys, one final thing that we should definitely do after creating a model, right? So in short, like let's say if I want to probably take this model and deploy it into production. So in what format I can probably take it up so that the prediction can be done over there in the cloud. So for that, we will be using a pickling concept. Now, what exactly is pickling? I will just give you a definition over here for you all so that you can refer it. Okay. So what is pickling? Okay. Pickling. Okay. So here, I will just say markdown. So Python pickle module is used for serializing and deserializing a Python object structure. Any object in Python can be pickled so that it can be saved on the disk. So similarly, regressor also, this regressor model, we can pickle it and save it on the disk so that once we deploy that particular file into the cloud, we will be able to give the input and get the output. Now, how to probably perform pickle? It is very much simple. I will be importing a library which is called as pickle. And here I will just say pickle.dump. Okay. And I will probably say regression. Okay. comma, I will just use open function in Python, and I will open a file which will be like, let's say regressor.pickle, and this will be opened in the write byte mode. Okay. So write byte mode basically means we'll try to create a .pickle file. The extension will be .pickle only, PKL. You can also have another extension. There are some extension which this pickle supports like .sav and all. But here we will be using .pkl file. Okay. Now all these things are there, and what we will do is that we'll just try to dump it. Okay. So once we dump it, so here you can see object cannot be interpreted as integer. Okay. There is some problem over here. No worries. So now I will go and execute it. I had closed the bracket early, right? Now, if I probably go over here, so this is my pickle file. And if I open this pickle file, I'll not be able to open it because this is a UTF-8 encoded. So it will basically be in this serialized format. Okay. So now I have my pickle. It is stored in the hard disk itself. Now, if I want to upload the pickle or load the pickle, I will just go ahead and write pickle.load, and I will say open function, give my model.pickle file, pickle file, and here I will go ahead and basically write my read byte mode so that we'll be able to read it. Okay. So once we load it and save it in a model, now this model variable, let's see what is the error, model.pickle. Okay. I have to use this same name like regressor.pickle. Okay. So I will go ahead and write regressor.pickle. Now once I open this, now I can probably do model.predict and give my data, whatever data I want, like X test, and do the prediction. So done. The same model will be acting in this specific way only, how my previous regression model was actually happening. So in short, I'm creating this as a file which is in the serialized format. I'll be saving into the hard disk, and I can probably load this again and do the prediction, right? So this way we basically save the model. Okay. So I hope you're able to understand about the pickling concept. I hope you were able to understand about this entire model training with respect to the multiple linear regression. This was it for my side. I will see you all in the next video where we will be discussing about the polynomial regression, right? So yes, I will see you all in the next video. Thank you.